In the previous movie, we finished building our foot rig and made sure it abided by our cleanup checklist. In this movie, we'll begin work on our arm rig. Start by opening the file Character Rigging, Part 22 Start, or by using your own file from the previous lesson. The beauty of an arm rig is that it is functionally similar to the leg rig, which we tackled in parts 10 through 18 of this series. In many ways, you can consider it a review of what you've already learned in previous parts of this tutorial. Since the foundation is basically the same as the leg, you'll see we've already started you off with a trio of IK, FK, and result arm joint chains. You can refer to part 10 of this series for additional help on how this trio works. Both IK and FK arms already have control curves associated with them, as well as a left arm setting control with an attribute to switch the result arm between them. Each arm also shares identical local rotation axes, which we set to XYZ with -y as second axis world orientation. Why did we choose to point the y-axis down? Observe how bending the FK arm inward is a positive rotation. Remember when we created our FK leg in part 10, we highlighted the importance of positive rotation being the natural rotation direction of a joint. The same goes here and ensures consistent rotation values during animation. We've also set the forearm and hands rotation orders to XZY and ZYX respectively. This will enable us to bend the arm forward as well as side to side while still maintaining twist. This also ensures consistent bend and side motions between the arm and hand joints. Now we could just accept this as our base arm and proceed to the next step, but let's take a moment to think about the arm's twisting motion. Unlike the leg, which typically stays parallel to the body, except in some fairly rare scenarios, the arm's twist range is much broader depending on what the character is doing. If we think ahead about how this arm twist will impact the character's skin later in the production pipeline, we'll need more joint segments to allow better deformation. To that effect, let's use some techniques we learned when creating the torso to build a twistable arm for our result joint chain. Start by hiding the IK and FK arms so only the result arm is visible. Let's also unparent the left arm geometry from the result arm. Since we want to give the arm some more definition while twisting, we'll need to divide it into more sections, just like the torso. We could choose to delete the current result joints and start fresh, but it's actually quicker and more efficient to use these existing ones with proper local rotation axes as a base, since the new joints we'll create will inherit these attributes. First, duplicate the result joints, then hide the original chain. We'll use the Insert Joint tool to add new joint segments between the existing joints. Select Skeleton, Insert Joint tool. Now click and drag from the duplicated left arm result joint. Maya creates a new joint that moves along the bone. Place this joint and then use the tool again to insert a total of 4 joints. Now, in pivot mode, point snap the chain's end joint so it overlaps the forearm joint. While you're still in pivot mode, move the other joints so they're roughly evenly spaced. It's very important that you move them only along their x-axis to keep the joint chain straight. Once you've spaced them out like this, rename the joints left upper arm seg joint 1 through 5. Now in the outliner, unparent the left forearm result joint and repeat the exact same procedure so you have 5 forearm section joints. Delete the left-hand result joint and left-hand end result joint from this duplicated chain, since we won't need them for this twist chain. Now switch to the front view and use the Polygons menu set's Edit Mesh, Cut Faces tool to create edge loops around the arm geometry at each of the segmented joints. Highlight the faces of each section and use the Mesh Extract command to extract them each into their own mesh. Delete the history on this geometry and rename them accordingly. Parent each section of geometry to its respective joint, making sure to center its pivot on their parent joint so that it rotates correctly. Delete all the leftover empty groups. Now you can individually rotate each part of the arm, but it should go without saying that the animator would prefer not to do this manually. Just like the torso rig in part 2, we'll set up an IK spline to automatically manage this rotation. However, before we do that, let's consider the difference in movement between the arm and torso. The torso can twist, but it can also bend in multiple places. Conversely, your arm, aside from the shoulder, can really only bend in two places, at the elbow and at the wrist. That means we need to create a spline curve that can twist but not bend for both the upper arm and the forearm. Our spine can bend because there are multiple control vertices, which have a weighted influence over the various spine joints. However, if we eliminated the middle control vertices, the curve wouldn't be able to bend, and so the joints wouldn't either. To that effect, let's manually create a spline curve. Go to the Create EP Curve tool settings and set its curve degree to 1 linear. Using point snapping, draw a curve from the first upper arm joint to the last. Go back to the animation menu set and use the skeleton IK Spline Handle tool with the Auto Create Curve option turned off. This will allow us to tell Maya to use our own curve instead of having it generate one for us. Holding Control, select the first and last joint, then the curve you created. Maya creates an IK spline using the selected curve. Rename the effector, curve, and handle appropriately. Next, we need to create bind joints to control our IK spline curve. Duplicate the upper arm joint chain. Unparent the last joint, and delete the node hierarchy under the first joint. Rename the two remaining joints left upper arm start bind joint and left upper arm end bind joint respectively. Select both joints and the curve and go to Skin, Smooth Bind options. Reset the settings, then set Bind to selected joints and max influences to 2. However, we still can't twist it yet. For that, we'll have to go to the IK handle's IK Solver attributes, Advanced Twist Controls, and activate its twist controls. We want to set the World Up type to Object Rotation Up Start End, and use our start and end bind joints as the world up objects. Due to the orientation of the twist joints, we'll set up axis to positive Z. And due to the orientation of the bind joints, we'll set their up vector to positive Z each. Perfect! Now the upper arm twists. Repeat this entire procedure to create a twisty forearm as well. Note how we've reused the left upper arm end bind joint as the start bind joint for our forearm. We recommend doing this so the forearm and upper arm always twist in sync. To make this clearer, let's rename it to a more generic left arm mid bind joint. Also rename the left upper arm start bind joint to left arm start bind joint, and the left forearm end bind joint to left arm end bind joint to match. To control the arm, we'll parent constrain each of the bind joints to the old non-sectioned result arm. For the upper arm though, we'll just use a point constraint, since we'll be building a shoulder rig in an upcoming movie that will better handle the orientation. Unhide the result arm and reparent the left hand geometry to the left hand result joint. Now if you rotate the result joints via the active IK or FK driver chain, the segmented arm twists. You can also bend the arm in only the appropriate spots. To keep the outliner clean, let's also group the curves and IK handles in a group called Left Arm Twist Group and hide it. In the next movie, we'll look at how to add squash and stretch to both the IK and FK arms.